Next question is, a retail company is operating its e-commerce application on AWS. The application runs on the Amazon EC2 instances behind an application load balancer ALB. The company uses an Amazon RDS DB instance as the database backend. Amazon CloudFront is configured with one origin that points to the ALB. Static content is cached. Amazon Route 53 is used to host all public zones. After an update of the application, the ALB occasionally returns a 502 status code bad gateway error. The root cause is malformed HTTP headers that are returned to the ALB. The web page returns successfully when a solution architect reloads the web page immediately after the error occurs. While the company is working on the problem, the solutions architect needs to provide a custom error page instead of the standard ALB error page to visitors. Which combination of steps will meet this requirement with the least amount of operational overhead? Choose two options. And the options are: option A, create an Amazon S3 bucket, configure the S3 bucket to host a static web page, upload the custom error pages to Amazon S3. Option B, create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check responses target failed health checks is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point a publicly accessible web server. Option C, modify the existing Amazon Route 53 records by adding health checks. Configure a fallback target if the health check fails. Modify DNS records to point a publicly accessible web page. Option D, create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response ELB.internet error is greater than 0. Internal error is greater than 0. Configure the Lambda functions to modify the forwarding rule at the ALB to point a public accessible web server. Option E, add a custom error response by configuring a CloudFront custom error page. Modify DNS records to point to a publicly accessible web page. Correct answer is option E. Add a custom error response by configuring a CloudFront customer error page. Modify DNS records to point a publicly accessible web page. Next question is, a company wants to use a third-party software as a service SaaS application. The third-party SaaS application is consumed through several API calls. The third-party SaaS application also runs on AWS inside a VPC. The company will consume the third-party SaaS application from inside a VPC. The company has internal security policies that mandate the use of private connectivity that does not traverse the internet. The resources that run in the company VPC are allowed to be accessed from outside the company's VPC. All permissions must conform to the principal's at least privilege. Which solution meets these requirements? And the options are: option A, create an AWS Private Link Interface VPC endpoint. Connect this endpoint to the endpoint service that the third-party SaaS application provides. Create a security group to limit the access to the endpoint. Associate the security group with the endpoint. Option B, create an AWS site-to-site VPN connection between the third-party SaaS application and the company VPC. Configure network ACLs to limit access across the VPN tunnels. Option C, create a VPC peering connection between the third-party SaaS application and the company VPU update route tables by adding the needed routes for the peering connection. Option D. Create an AWS private link endpoint service. Ask the third-party SaaS provider to create an interface VPC endpoint for this endpoint service. Grant permissions for the endpoint service to the specific account of the third-party SaaS provider. And the correct answer is option A. Create an AWS private link interface VPC endpoint. Connect this endpoint to the endpoint service that the third-party SaaS application provides. Create a security group to limit the access to the endpoint. Associate the security group with the endpoint.